The aim of our project is to construct a housing design that will be cost-effective, culturally acceptable, provide a safe dwelling that will withstand all types of weather, and provide occupants with comfortable living conditions. The design has two key elements. Firstly, the ventilation ridge. This feature has the ability to be lifted, allowing hot air out and allowing cool air in turn reducing the heat inside the house. Secondly, combined with the internal layout design and a specifically modified shutter system, air is easily able to move freely through the house.
As with any new proposal, it is important to consider the cultural, environmental, technical and environmental aspects. The design is in keeping with the existing culture and does not differ significantly in appearance or material choice to what already exists in the Mekong Delta. Metal sheeting, thatching and bamboo and melaleuca timber are all widely used and accepted. The layout supports a multi-generational family unit, which is common in the area, with an integrated bathroom, sleeping area and work area. The design has included the use of bamboo and melaleuca for framing and stilts from the Vietnamese forests, which are now being sustainably managed and monitored by the government. The proposed metal sheeting is manufactured in Ho Chi Minh City by BlueScope Steel and is 100% recyclable. The ridge and shutter mechanisms will be manufactured in the regional capital, and the construction will utilise pre-cut components to minimise waste. The locally sourced thatching will give an authentic appearance to the new houses. The skills required for the installation of the rising ridge mechanism and the window shutter mechanism are basic and will be able to be taught to the owners and local tradespeople, thus keeping money in the local economy. The design incorporates 5 principles to provide cooler living and more comfortable conditions for the inhabitants. 1. The house will utilise light-coloured metal sheet cladding to all wall and roofs to keep the building watertight and reflect heat. 2. The building is to be orientated so as to catch the prevailing southerly winds of the area. The southern elevation will incorporate a large 3 metre by 1 metre opening, and air will travel through the house to the smaller windows on the north elevation. The centre wall will be perpendicular to these openings to allow free air movement. 3. Warm air will be released via a raised roof ridge, which will be operated manually by a mechanism in the centre wall. The ridge will be held in place by inserting pins after lifting. The model showed that this was a simple operation. The ridge can be quickly lowered in adverse weather. 4. 1 metre long roof overhangs will shade large amounts of the external wall from the sun, keeping conditions cooler internally. 5. Coconut leaves or thatching are fixed to the metal sheeting to assist with cultural integration, but also to provide insulation properties. Housing and Construction Team No. 1's design utilises the following construction method. Firstly, planning and design will dictate the most appropriate floor level to prevent damage from floods and the best orientation of the house to catch the prevailing winds. Cutting lists will then be provided for manufacturers. If building over water, the treated bamboo stilts will be installed to suit the floor framing layout, and the floor framing and marine ply will then be constructed. If building on land, concrete footings and concrete slabs will be installed. The ridge and operating mechanism will be fitted once the wide internal wall has been erected. The thatching will still need to be replaced every 3 years, but the quantity is now 60% less than that currently being used. Thatching will be fixed to the external sheeting at a coverage rate of 50% and to the internal walls at a coverage rate of 100%. The fit out of the bathroom, joinery, kitchen, lights and curtains can now be actioned. The construction should be checked for watertightness by visual inspection, and the mechanisms to the ridge and shutters should be tested. Local labour can be utilised for all aspects of the construction and maintenance periods. Community engagement will be required to deliver the philosophy of higher initial costs versus lower maintenance costs. This will need to be done with the highest ranking males from the family and the community, which is the usual custom of the area.
Issues and constraints surrounding the design. Tools may differ, making it difficult to join certain materials together or properly. The pulley system needs to be redesigned. As it is currently, it could be difficult to raise or lower for those who are elderly, weak, or somebody trying to do it alone. A locating bracket on the roof would be ideal, as the ridge will sometimes come down out of place, leaving gaps which are susceptible to the elements. There may be difficulties attaching the thatching to the roof because of the different tools required, and also creating holes in the iron roofing to fix the thatching would cause waterproofing issues later on. The shutter control was not 100% successful with the cable grabbing as it passed through the wall. On site, a sleeve with rounded ends should be used so this does not occur. A latching system will be also required when closed to counter winds and storm. Proving and explaining the higher initial cost benefit over the existing structure will be an issue, as the area is one of the poorest in Vietnam and receives little or no government aid. The cost will affect size, material selection, and the complexity of the build. Issues could arise over the acceptance of the full metal sheeting used for the building. As with any building, ongoing maintenance will be required. The items requiring the most attention will be the thatching and having to replace it as necessary, and regular inspections of the shutters and the ridge mechanism, and replacing or repairing components as necessary also.
As you can see here, by pulling this pin out will allow the ridge to lower during wind and storms. In turn, using the pulley system to raise the ridge will allow hot air out and cool air in. In this demonstration, you can see how the wind easily moves through, which contributes to the cooling process.